So now we are going to study the viscosity. Viscosity has an important properties of fluid. And viscosity is nothing, it is just resistance offered by the layers of fluid. So how to understand? We will easily understand through this diagram. Suppose these are the layers of flow, water flow. That is a control volume, fluid, and we divided the whole water into the layers. Okay, that is one layer, two layers, and this. That is a base. Okay, so each layer exerts a resistance on each other. So when we see that at the above point, these layers having some resistance on that above layer. So at this point, this layer having the maximum velocity, and whenever we will come down, okay, at this layer, it having some mass over it, okay, and obviously it will offer more resistance as compared to this layer. Okay, when we come to this point, resistance will increases. Okay, so it's a very common thing that's the as we are moving to downward direction. Okay, resistance offered by the layers goes on increasing, means that velocity is decreasing. If we plot a diagram, it's a clear thing. That is a layer of flow. Okay, we divided the whole flow into the layers. Suppose that is the water 3D. Suppose this. Okay, that is some water flowing through it, and we divide it into the slices. One layer. Okay. Second layer. Third layer. These are the layers. Okay, layers. Fourth layer, something like that. So they are flowing. They are resisting some rupture resistance like that. This one. Suppose there is one layer. Okay, you're watching. There's a one layer. We're putting over there the second layer. When there movement, okay, it will resist some resistance. The resistance offered by the layers is the viscosity. So through this diagram, suppose that is the upper point. This 0. That is a base. At the base, maximum to the maximum frictional resistance, maximum weight on this layer. Suppose we are taking this layer, it having the whole mass. Above layers, the weight of the whole layers it considered. So resistance will be more and the velocity will be least. So we will get like this diagram. That is a what's the lines of velocity u, and that is depth y. Okay, so we are watching there is a velocity gradient existing within it. As we are moving in the downward direction, velocity is decreasing. At the base, velocity will be 0. Shear force will be a maximum. So what we are saying, that is the velocity is continuously decreasing as the depth is decreasing. So there will be some velocity gradient. Suppose dy, and this change in velocity is du. So what will be the gradient? Du by dy. Velocity gradient. Clear? Velocity gradient. Okay. So each layer is resisting a shear force on that. So how to define the viscosity? Each other. Reading point. Whatever the layers, these layers 1, 2, 3, 4, 4. They are exerting some resistance over it, which is a viscosity property known as the viscosity. So shear force is whatever the shear force acting between the layers is directly proportional to the velocity gradient. Knowing this, that is our velocity profile, some velocity gradient du by dy. So shear force, what is the shear force? Shear force is equal to mu du by dy. Coefficient of dynamic viscosity. So that is a shear force. Velocity gradient. If mu is not visible, it is a dynamic coefficient of viscosity. Dynamic coefficient of viscosity, that is mu. So shear force is equal to mu du by dy always. Du by dy is a velocity gradient existing between the layers. Okay. Then what will be the unit of mu? You know, unit of the shear force is Newton per meter square. Unit of velocity meter per second, and unit of depth is meter. When you will equate, you will get Newton second per meter square. Okay, Newton second per meter square. Meter square. Let's zoom in. Okay, so that is a MKS system. Okay, now we will know